Hello everyone, the Instant Camera Guy here, and welcome to what will hopefully be one of the final parts in my series of refurbishing the dead on arrival PolaVolt Alpha M SX-70 camera. Those that have been following the series will know that the entire reason I was sent an Alpha M was to PolaVolt modify it, and in exchange for my PolaVolt mod, I was going to leave the rest of the camera intact. I was basically going to do a review of the Alpha M, and it also so happened that I wanted to update my PolaVolt video anyway because I've revised my technique of how I do it, and so it was going to kill two birds with one stone. To cut a long story short, this is all that remains of the original. Yeah, the camera was completely dead on arrival. It's been a whole saga trying to get it to work, but I can only come to the conclusion that the board itself is faulty. So I have converted this to become an SX-70R PCB. I've refurbished all the other issues that the camera had because this thing has been one heck of a journey. It was pretty much completely trashed when I received it. It is now up to spec, and I wanted to show you guys my newest method of PolaVolt modifying the camera. So, first of all, if you're new to the channel, what on earth is a PolaVolt, I hear you ask? Well, the PolaVolt is a compact, powerful lithium-ion battery I-type solution for SX-70 style cameras, which is incredibly powerful. It's very small, and most importantly, it is open source and made entirely from off-the-shelf components. Of all the different repair techniques that I have had a hand in inventing and perfecting over the years, the PolaVolt might be one of my proudest achievements. The thing that separates the PolaVolt from other I-type battery solutions, in addition to those things that I said, you know, for example, the fact that it's made from off-the-shelf components, the thing that separates it predominantly from every other I-type adapter on the market is that this adapter, unlike any other, is integrated into the camera itself. So it's not an adapter that you kind of clip on per se, like many of the other adapters out there, which either replace or attach to the camera somehow. This is wired into the camera's electronics, and what that means is you don't need any switches or anything like that. It's simply you erect the camera and it turns on, and if you want to turn the batteries off, you just collapse the camera. There's no need for any power indicator or anything like that. It is just simply a matter of closed is off and erect is on. Simple as that, really. And that's what separates it from the rest, as far as I'm concerned. That might not sound like a very big deal, but trust me, it is so nice being able to just open a camera and be able to take a photo instead of having to remember to, oh, that's right, I got to turn the power adapter on. It's not until you miss a shot because your camera wasn't powered that you'll realize that external I-type adapters can be a little bit frustrating. So my solution here basically eliminates that by being built into the camera. And the way that it works is we are going to recycle the hinge switch inside the back of the camera, and we are going to rewire it so that instead of cutting power to original battery terminals that would have existed on the original packs of SX-70 film, we are going to bridge that and recycle it in such a way so that it will instead be cutting power to a set of 10440 3.7 volt lithium-ion batteries, which are being down converted to 6 volts using a DC to DC converter. All will be revealed in just a minute in terms of how to actually wire that up. But yeah, in a nutshell, that's what this is. It is a AAA battery holder, a set of 10440 3.7 volt lithium-ion cells, and a DC-DC converter and a few wires. We wire it into the camera in such a way that it recycles the camera's built-in switch, which pre-exists anyway, and what we end up with is an incredibly powerful, compact battery solution, which is very cost-effective and also is open source and easy to repair. Now, on the subject of open source, if you are going to be offering this as a commercial service, you know, you're a technician out there and you're doing this to make money and improve your clients' cameras, I do ask one thing, and that is that you credit me. If you are going to advertise this as being a PolaVolt, well, first of all, please do it in the way that I show you. Don't invent your own twist that's inferior to the way that I do it. More on that later in the video, hopefully. But yes, please give me some credit. That's really all I ask. Otherwise, feel free to use it to your heart's content. So, what are we going to need in order to do this? Well, the first thing that we're going to need is obviously a refurbished SX-70 camera. Now, I really want to emphasize this. If you think that this I-type solution is going to magically bring your camera back to life and give you amazing performance, you are mistaken. The PolaVolt conversion should only be done after the rest of the camera is fully serviced and overhauled from the ground up, and the shutter is converted to 600 type film. Because remember, SX-70 cameras are originally supposed to be calibrated for 160 ISO film. I-type film is 640 ISO, so at the very least you are going to want to do an original capacitor modification if you're using the stock PCB, or you're going to need an upgraded PCB such as the SX-70R board, which I have installed in this camera. So yeah, you're going to need a fully refurbished camera. As I said, I can't stress this enough. You cannot expect good results if you simply do the battery conversion and leave everything else untouched. That's a really bad idea. And the reason that I said before, if you're going to do this commercially, you know, please do it the way that I'm showing you and do it properly, because I've had a few people over the years contact me and go, "Oh, hey Jake, you'll be really excited about this. I discovered you don't even need to open the camera up to install the PolaVolt. You can simply solder to the bottom terminals and run wires under the leather." And oh my God, I've seen so many very terrible variations of the PolaVolt that completely miss the point of the original. The PolaVolt is not batteries and a buck converter. That's been invented in the past. What separates my PolaVolt is how it's wired into the camera. So if you just add batteries and a buck converter and you say it's PolaVolt modded, no. What I invented is the method of wiring it in. I didn't invent anything else. I didn't invent 10440 cells. I didn't invent buck converters. I didn't invent anything. What I invented here is the method of how to wire it in, recycling that original hinge switch and repurposing it. That is what I'm talking about, right? Doing so with a toggle on-off switch, nope, that is not PolaVolt. PolaVolt only applies to battery adapters that recycle the camera's original switch. It is only if you recycle an original switch inside the camera that you can call it a PolaVolt. Anything else is not only inferior and misses the point of my invention, but can end up being dangerous because of leaving original battery terminals in there and 600 packs of film, and the buck converter has voltage going where it's not supposed to be. It's just not a good idea. If you're going to do this, follow my directions, do it properly. So, we need a fully refurbished camera. We need to be willing to do things as I'm about to instruct you. We will, of course, need some 10440 lithium-ion cells. Why do I choose 10440 lithium-ion cells? Well, they are the same shape and size as a AAA battery, and that means that we can use regular old AAA battery holders, right? Just from your local electronics store or online, you can get these just about anywhere. All the parts that I'm showing off here, they're all commodity. These can all be found on Amazon or eBay or AliExpress or any good electronics store like Mauser, RS Components, DigiKey, all that kind of stuff. And the reason, because I do have some people that criticize this, oh, well, 3.7 volts, it's a strange battery, like what happens if someone uses regular AA's? Again, I must stress, I chose these batteries not only because they're easy for users to replace, because, well, everyone knows how to replace a AAA battery, but it means that we can get away with buying off-the-shelf battery holders. Simply put, a injection molded ABS plastic battery holder like you see here not only are they cheap, but they're very, very strong, right? Like these are very, very durable. They are way more durable than something that is 3D printed, and they're easily replaceable. You can buy these, as I said, just about anywhere. In addition, if you are silly and you've somehow ignored the fact that this uses 3.7 volt lithium-ion batteries, despite every video that I've ever done on the PolaVolt informing you multiple times that it uses 3.7 volt lithium-ion batteries, well, what happens if you put like regular 1.5 volt alkalines? Just nothing. Nothing will happen. The camera won't turn on. So there's really no issue. If you use the wrong type of batteries in the PolaVolt and you try and power the camera, it just won't turn on. It's as simple as that. So there's no risk of damaging anything, and that I think is one of the best parts about the PolaVolt, because it's quite foolproof in its operation. Even if you went out and installed the wrong batteries, it's not going to damage the camera. In fact, nothing's going to go wrong at all, because all that will happen is the buck converter will try and, it's designed to reduce voltage only, and it can't reduce 3 volts to 6 volts. That's impossible, so it just won't do anything. So yes, you'll need the battery holder. You will need some automotive grade double-sided tape. I use foam body molding tape. This I find is the best way to attach it to the body of the camera. This stuff is insanely strong. Once it is pressed on, it ain't coming off again unless you go out of your way to remove it. You could, of course, use small screws if you want to. That's completely up to you. I find it simpler to just use double-sided automotive body molding tape. You will also need some thin gauge wire. How thin? Well, this is about the thickness of wire that you would find inside a USB cable. If you're unsure of where to buy thin gauge wire, or you can't find any locally, find like a VGA monitor cable for like an old monitor, or find like an old printer parallel port, cut it, strip it, and take the wires out of that. That's effectively what these are. These are the same type of wire that you would find in like a 9-pin monitor cord or 9-pin computer cord. Don't use the original leads that come with the battery holder. This wire here is much too thick. I see so many people do DIY versions of the PolaVolt, and the battery wire that they're using is twice the size of the wire that I recommend. It is just going to make your job so much harder, and it's going to make it harder to fit the bottom panel of the camera together. So please go out, get yourself some good thin wire. It's going to make your life a lot easier. You will, of course, also need the buck converter. This is what they call a mini 360 DC to DC converter. These are what they'd call a jelly bean part. These are like everywhere online. You can pick these up on AliExpress, eBay. It's basically a little board with a buck converter chip, an inductor, some smoothing capacitors either side. It has a trim pot so that you can adjust the voltage. I believe you can put really any voltage into one of these. I think you can put all the way up to like 24 volts in there. Don't quote me on that. I definitely know 12 volts is fine. I think it goes up to 24. We're going to be putting in about 7.4 volts into this, and we need to adjust that output so that it outputs 6 volts. Now, you could use the built-in trim pot that's in there. I wouldn't recommend that because it's very easy to nudge and have it output a different voltage. It only takes a little tweak to alter the voltage quite dramatically. So a little nudge could be the difference between outputting 6 volts and 6.5 volts, or even 7 volts. So when we go to install this, I'm going to remove this trim pot and replace it with a 46.4K resistor, of which I have a whole stack here. Again, you can buy these from any electronics supplier. You basically just need any package that's going to fit on the pads where the trim pot is. You could use a larger resistor if you wanted to run wires, but yeah, anything that's the same size. So make sure you're looking at the package size of the surface mount resistors that you purchase. 46.4K, I tend to find is fine, but that may vary depending on the exact chip that your DC to DC converter uses. So be sure, if you have a chip that if you have a buck converter that looks slightly different to mine, what you want to do is just measure the output voltage, do a bit of a bench test just to make sure. If it's about 6.1 volts, even up to 6.2 volts, that's going to be fine to power the SX-70. You don't really want to go any higher than that, and you certainly don't want to be going lower than 5.9. 6 volts is that sweet spot that we're aiming for. So I think that's about all we're going to need. The other thing that you'll need is some Kapton tape, some electrical tape, and I'll show you why in just a second. Now, I've already started on this camera in another video, so I want to show you two things that I've done to this that I otherwise can't demonstrate. And to do that, I just have this beat up old chassis of an SX-70. In previous videos, I used to cut various different traces in order to alter the way that the circuits worked. I don't need to cut anything anymore. I've actually found ways that you can bypass that. But to get the PolaVolt to work, one of the things that we need to do, if you're going to use a stock PCB especially, we need to disable the automatic eject. And the auto eject works using these switches on the film counter. So one way that you can disable that, you can simply cut the traces that go to these two switches at the very end here, these ones here. Or, if you follow those traces, you'll realize that these two pads located towards the front, where the shutter cable goes, those are the ones that go then up into the shutter that are responsible for the auto eject. If we insulate those two little pads and just simply don't connect them when we solder the shutter back on, they're not going to be connected, and so the film counter is going to be completely ignored. So one way that I found that you can do that is just simply using some tape. So again, I've got my high temperature Kapton tape, and again, you could simply cover those front two pads. Cut that. So hopefully you guys can see exactly what it is that I'm doing. So I've completely covered those two pads at the front, and we'll tuck that tape over. And that's it. When we solder on that shutter, we're only going to use those rear 5 pins. We're going to completely ignore those front 2 ones. And by doing so, we've now just disabled the automatic eject. Now, if you're using an SX-70R PCB, the auto eject is disabled anyway, so you could skip that step. But if you're using a stock PCB, you absolutely will have to do that. Auto eject and the PolaVolt are simply not compatible, because if you were to leave auto eject enabled, the SX-70 is not designed to be powered without a pack of film in it. So what's going to happen is if you take the film out and close the door and you erect the camera, it's going to constantly try and cycle that dark slide, and it's going to close your shutter blades and leave all the electronics running. It's a bad idea. So trust me, a little bit of tape, tape up those two pads. That is step 1. Step 2, and again, you would do this normally while you are fully refurbishing the camera. So you're going to have the thing open, you're going to be cleaning the Fresnel screens and the mirrors and lubing the gear train and doing all that stuff that I've shown you in other videos. But what we're going to do now is we're going to rip out those original battery terminals, these little copper pieces here. In previous videos of wiring in the PolaVolt, I actually used to desolder the entire thing and remove the entire board from the bottom of the camera. You could also cut those traces. That would be one way of doing it. But I honestly find that the best way of doing it is to just reach in and remove the terminals completely. This is the easiest way. Now, if you wanted to leave the bottom ribbon cable completely intact, you could just desolder those parts, insulate, and then just tuck the ribbons on top. I like to just completely remove the terminals, because with those terminals removed, there is now absolutely no chance whatsoever that any electricity can go from a pack of film and into the buck converter the wrong way around, because that's what's going to happen if you leave those terminals in place. Inserting a pack of 600 film will send voltage onto the output side of the buck converter, which isn't good for it. So first step in wiring the PolaVolt up is insulate the front 2 pads and either cut traces to or remove those battery terminals entirely. I find that that's the easiest way to do it. All right, now, as you can see, I've already done those steps to this camera here. This camera is otherwise pretty much ready to go. Now we can focus on soldering in the wires. So the first thing that I'm going to do is I'm going to grab some solder wick and I'm going to desolder the parts of the ribbon cable that attach to the rear switch. But yeah, doing the technique this way is the least destructive, if that makes sense. So it also takes a lot less time. Like cutting and insulating all of the ribbon cables was very fiddly. Once I figured out you didn't have to go that extreme, I changed my technique and I've been doing it this method ever since. It's just a lot easier. I also no longer, in a Model 1 camera, I don't run leads to the original battery terminals anymore. Like I used to run a wire going across and onto that part of the board for the negative. I don't do that anymore. I just wire in all Model 1 and Alpha cameras using this same technique. Now that will change how the door switch behaves in a Model 1, but honestly, it's not a problem. I'll hopefully talk a bit more about that at the end. All right, so with the ribbon cable pulled up, what we're going to do now is add some solder to the two sides of the switch. So we'll see those two little brass terminals there. I want to add some solder because we're going to be running a wire off of either side, and I'm going to add some solder to the top of the ribbons as well. So, like so. All right. So we've now got nice big blobby pads of solder ready to accept wires. Now it's good practice to use a bit of alcohol and a cloth to just clean those cables as you're going. I like to just put a little cardboard pad under here for support so that I can really wipe the tops. The reason that I'm wiping it down and getting rid of the flux residue is I am going to insulate this at the end using Kapton tape to be 100% safe. And it's just going to stick better to a clean surface, that's all. All right, now we've got some wires. Now, you are going to need a bright color and a dark color for positive and negative. That's just like an industry standard. So I think for positive, we can use white. For negative, we can use black. And for the switch, we can just use this orange wire. Colors don't matter. It's all the exact same gauge of wire. So what I'm going to do is, just using some scissors, I'm just trimming the ends. I've got a little piece of blue tack here. I like to use blue tack when I'm soldering, just to hold things down. I've often had comments in the past saying, Jake, why don't you get one of those little claw machines? I don't like them. They're too time consuming to set up. And blue tack is incredibly cheap and does the same job. Blue tack's also a lot more portable. I can hold this wire anywhere I want. So that's my little top tip. Little claws can be good for soldering, certain projects, especially if they're very fiddly, but for wires, blue tack is going to work fine. All right, so I'm just going to run the first wire and probably leave about that much hanging off. And then I'll try and show you guys on the camera. Again, I use single camera angles mostly when I do these repairs. I have done other videos on the PolaVolt. But a pro tip, I record everything in 1080p, which is a pretty high resolution. If ever there's something that you're having difficulty seeing, on the app on your phone, you can actually do that reverse pinch and it will zoom in. Or if you watch on a smart TV, the image is going to be huge, and you'll be able to very easily see what I'm doing. The only time it becomes difficult sometimes is when you're on a phone. But a phone you can zoom in. Not a lot of people know that about YouTube app on the phone. Which is pretty crazy. All right, so I've wired the orange wire either side of the switch. So what's going to happen is these orange wires are going to become continuous once the camera is erected. When it's collapsed, that's going to cut the trace to the orange wires. Now for positive, we can use this white wire. White being a very light color will indicate a positive signal usually. Generally positive is either like white or red. It can be green sometimes depending on the electronics. As I said, the colors, they don't really matter, but consistency does. But the general rule of thumb is if you have like a positive, you use a light color, and negative is a dark color. Now, this switch here is where we're going to attach the positive. So this is going to be plus 6 volts right here. All right. And again, we're just going to bring a decent length of wire over. Just put these to the side. Now we will need one more short little piece of wire very soon. I've already actually prepared one of the, hello, auto exposure. I've already actually prepared the battery adapter I'm going to use. I've already stuck the tape on, and the positive terminal outputting from the battery adapter here, I've already soldered this green wire to. All right, now that means the last wire we need is the negative. Now the negative wire, what I'm going to do, I'm going to just bridge it straight across those two pads on the ribbon cable. So I'm going to strip a little bit of extra insulation to make a nice long piece of metal here. And that's now going to just go straight across those two pads. So this is going to function not only to bridge the trace on the ribbon cable, but this also taps into the negative rail here of the circuit, and will serve as the negative input once it comes out of the buck converter. All right. The reason I'm putting the card under this, by the way, like I said before, is really just so that I can press down on things. If you solder directly onto those ribbon cables, you'll probably melt the bits and pieces that are underneath. So I like to just put that card in place. Now we can remove the extra piece of wire off the end. And that's pretty much it. Now we get to insulate things. So I'm just cutting up some Kapton tape into little rectangle strips. So it's really just this piece now that needs to be insulated. Okay. Like so. All right. And of course we've got to cut this black wire down to size since it's currently way too big. One thing that I like to do, I've just cut a tiny little piece of heat shrink tube, and I'm going to put that over these 4 little wires just to keep them together. And then I'm going to also add some Kapton tape to those wires to just hold them in the position that I want them in. And this is going to make installing the bottom panel just that little bit easier, right? Can you see what I've done there? I've tried to flatten everything as good as I possibly can. And then we can take a piece of tape like so, like that, and just use that to hold everything in position. Tuck that in. I'll grab a cigarette lighter, and I'm just off camera. I'm going to shrink that little bit of heat shrink. Easy. And then I'm going to add just 1 extra bit of insulation at the rear switch again, just on top there like so. All right, and that is how the PolaVolt should look in terms of wiring. So we've got the orange wires going to the hinge switch. We've got the black wire bridging those 2 pads and then trailing off as the negative. And the white wire, which is the positive, I've soldered to that film counter nodule. So none of this has involved cutting or insulating any of the traces. As I said, you could completely keep everything intact and leave those battery terminals and just desolder, insulate, stick it back down. Again, I make my cameras as foolproof as possible. I have to be when I do this for clients, so I just totally remove the terminals altogether. But this is the easiest method that I have found to wire in the PolaVolt solution. Now, something optional that you can do is over here, this switch here is the door switch. Now, if you were to bridge those 2 connections, it would mean that the camera is powered on even if the door is opened or closed. Now, that does add an extra element of reliability for the camera because these switches at the front where the door is, they can fail. Additionally, the little plastic post that's inside the door, that can fail as well. So if you bypass that switch altogether by just bridging it, it will mean that the camera is always powered when it's erect, even if the door is open or closed. Of course, power will be cut if the entire thing is collapsed. If you wire up the PolaVolt this way in a Model 1 or some Model 2 cameras, tapping into the negative here will bypass the door switch anyway. So if you use the method that I've just used on a Model 1 camera, that door switch will no longer function as it should. As I said, I don't really care about that because it doesn't change the functionality of the camera at all. If anything, it adds a bit of extra reliability because especially in Model 1 and Model 2 cameras, that door switch can fail. So it's a bit of extra redundancy. It also does add possibly the ability to experiment with a bit of a hacky way of doing double exposures. If you fire the camera shutter while the door is open, everything will cycle like normal. The film will spit out a little bit, but it won't get picked up by the rollers. So then if you're careful, you can poke that piece of film back in, close the door, take another photo, and you've effectively taken 2 photos on 1 sheet of film. Now, you will probably get a few light leaks doing that technique, but you can do that method if you bypass the door switch. So if you want to do that, now is your chance. Otherwise, you can leave it. In this case, I'm going to leave it. All right, that means that all we've got to do is install the battery holder onto our bottom panel, drill a hole, pass the wires through, and solder everything up on the other side. So what I'm going to do here is, just using alcohol on a cloth, I'm just going to prep the body panel. Now, when it comes to the PolaVolt and the AAA battery holder, I have so many questions, like so many people ask, can I mount the battery holder symmetrically in the back like so? Because I mount mine off to the side, right? Like so, asymmetrically. The reason for that is, if you have a look inside the camera, the wires come off precisely where there's that little dip in the ribbon cable for the motor. If you mount the battery holder more symmetrically, you have to mount the wires pretty much underneath where the driver chip goes, and it's a lot of a sharper turn. So I like mounting it asymmetrically because it gives the cables the most room. Less pressure on the cables means they're less likely to bend and snap and fray. Also, doing it asymmetrically also provides better access to the film counter. If you put it right in the middle, you obscure it quite a bit. If you put it off to the side, you give yourself the best possible viewing angle. So what I'm going to do is just peel back the double-sided tape. Now, the best way to align the battery compartment is where the strap plug is on a sonar camera. You want the edge of the battery adapter to be in line with it. Can you guys see that? On a Model 1 camera or a camera without strap plugs, you can do the same thing, but you'll have to put it 13 millimeters from the side. So 13 mils in, and that's the position where it'll be. But on a sonar or any camera with strap lugs, you can just use the lugs to orient yourself. So I'm just going to stick this bit on. Then I might take a little break because my camera's running out of charge. And I'll come back and finish showing you how to wire everything in. So we'll just make sure that that's 100% clean. So I like to have it nice and flat. And press it on very lightly. Make sure everything is square. And then you can press it on nice and firm. And once it's firmly pressed on, it ain't coming off. This is an incredibly strong tape. Now, drill with a 1/8 bit. We're going to put a hole through the base of this body panel and going onto the inside. Then I like to just use a larger drill bit, such as this one. I think this is, what, 6.5 mil. I like to just round the insides of that hole. Again, I don't want any sharp edges pressing on the wires or fraying anything as I'm wiring this up. That's it. So now we can take the door off the camera. We can run the wires through and put the bottom panel on. All right. So I'm just slipping the wires through, all 4 of them. Grab them from the rear. All right. Now what I'm doing, I'm having the camera open like this, and I'm watching as I close this panel down. I'm making sure that those wires stay in the correct position. I'm watching the ribbon cable on the side. And and making sure that everything fits as it should. All right, now I can put in the 4 screws on the bottom panel. Great. Now, if you have a portable test pack like I do, such as this modified reservoir adapter, or if you had an original reservoir adapter, at this stage you can use the original pogo pins to test and make sure everything is working. So we know everything's operational, we can hear the mirror going up and down inside. Now it is simply time to cut and fit the rest of the wires. So I'm going to try and show you guys as good as possible how to do that. One of the things I'm going to do, I'm going to take the negative terminal out of the battery compartment, and what I need to do is solder onto the back of that. So I've got to put a big blob of solder so that I can then attach one of the wires. And I've got my phone. I'm going to try and take some B shots to try and show you guys what I'm doing as I'm doing this. But through a lot of practice, I've effectively figured out like what lengths each of the wires need to be. So I'm just sort of pulling the orange wires to the side, and I'm making them, you know, just sort of big enough to curl up and touch the edge of the battery holder. And then I'll snip the ends off, and so I'll try and take a photo of this. Now this green wire is going to lay inside and down, so like so. So about there would be fine. You don't want these wires to be too long, or else you're going to have to end up sort of snaking them and pushing them in the little spot that you've got. Oh, in case it wasn't obvious, by the way, these battery holders come with a little switch inside, and effectively we remove that part. So we remove the switch, we remove the positive wire and the negative wire, and just using a little spludger, we also remove those black plastic posts that hold the switch in. And that little space where the switch used to be is going to be the space in which our buck converter goes, because there's plenty of room to fit it inside that little space once the switch is gone. All right. And that is the last of our wires cut. All right, so the way that this is going to wire in my particular case here, right? I'm going to take a photo on my phone, just to show you guys how I've done this. But just to remind you guys, green is going to go from the battery to the buck converter input. Orange is going to go from negative battery to the buck converter input via the built-in switch. Black is going from negative buck converter output into the ribbon cables to power the camera. And the white is going to plus 6 volts. So from the buck output, again, onto the ribbon cables to power the camera. So if we separate the wires, it's orange and green here, and then black and white on one side. Now, as I said before, one of the things that we really want to do is replace the trim pot with a fixed resistor. In order to do that, basically you're just going to, where the trim pot has 2 tabs attached to the PCB, with a hot iron, you're just going to press, and it will eventually just completely pop off. And now you can solder across the 2 pads here. Ignore this one up here. That one, you know, even if you break that trace off, it doesn't connect to anything, so that doesn't matter. But in between these 2 pads, you can now solder your new resistor. And the end result should look a little something like this. Can you see that? Where it's got a resistor now instead of the trim pot? All right, so first thing I'm going to solder on is the negative battery terminal. So that's going to go on one of the orange wires. All right, so now we can put that terminal in place. And again, I hope you guys can see what I'm doing. As long as everything fits, this step is sort of the fiddliest. Again, I've done this so many times that this has just become an art now. But now I'm going to start soldering up the buck converter. So we've got all the battery terminals attached now. I'm going to try and do this step by step. So input negative, get on there. Input positive. Come on. All right. Now, what we can do is poke those wires on this side, push the green wire up, and now we can solder the wires to the output. So again, I'm just trying to take photos of all of this. It's very tricky to get everything in focus. And the last wire if it wants to stay, All right. Now we are in. So what I like to do is just have that little buck converter dangling from the wires for a minute there, whilst we put our test batteries in and make sure everything works. So again, I'm going to take just one last photo of everything. So you guys can see. And stick some batteries in. These should be nice and fresh. And we'll just give it a test. Beautiful. All right. That's now working. So with everything confirmed functioning, we can take the batteries out and use some double-sided tape to stick that buck converter down and hold it in place. All right, I've cut a little rectangle of that same double-sided body molding tape. I'm going to stick it on the back of the buck converter, like so. Trim off the excess. Then what I'm going to do is just take the little piece of insulating tape off. Come on, there we go. And I've got a little piece of waxed paper here, which I'm going to stick to the back. And this is going to allow me to push the buck converter down into place and then pull it out so that it sticks. Press everything in, and that's it. We now have one mounted buck converter. The last thing to do is a bit of cable management, just pressing everything, making sure it's fitting exactly where it's supposed to. Easy. And yeah, that's it. We are officially done now. Now the last thing that I like to do is I like to take a little piece of cardboard dark slide, like the first sheet of film that gets ejected, the cardboard protective layer. So I'm just grabbing one off to the side here, and I like to just cut a strip fold it in half to make a little rectangle of cardboard, and we can just slip that in between the positive battery terminal and the inductor. And again, that's just going to add a little bit of friction and keep everything fitting nice and snug. Now the inductor is not conductive, so even if that battery terminal did touch, it doesn't matter, but I like to do that just to hold all the wire nice and in place. And now we can put the, what's the word I'm looking for? The little door on the back of the battery compartment, and obviously I've got to finish this camera, but that's it. That is one fully installed PolaVolt battery solution from start to finish on this client's camera. See how powerful that is. I'm going to reassemble this camera off screen and hopefully show you guys the finished results. All right, we have one finished camera with everything working exactly how I would expect it to. You'll have to forgive the small light leak in some corners of these photos. That happened because I was transferring film from pack to pack. But yeah, this camera now straight up works. Funny what a PCB that actually functions can do. I am very happy with the performance of this thing after it's been, overhauled properly from top to bottom, and I am highly confident that my client will love using this thing for years to come. As I said, the shutter is now completely functional. I actually went and put in the original solenoid that came with this camera back in, because viewers of the channel might remember that I swapped the solenoid just in case it was out of spec. Well, although the solenoid I did put in there worked totally fine, curiosity got the better of me, and I thought, you know what, I'm going to stick the original in there and really cement once and for all, was the board faulty or not? And yeah, I think that pretty much proves it. Absolutely bang on exposures, and a camera that should work now for years to come. Well, that about does it for this video series. Hopefully you've enjoyed the ride. I certainly didn't. This was one of the most frustrating builds I've ever had to do. Just having to redo so much bad quality work, getting ultimately no help in terms of diagnosing the issues. Yeah, 0 out of 10, would not recommend. Building this camera, including like recording all the videos and stuff, has taken me a mammoth amount of time. Simply put, I think I could have refurbished about 4 or 5 of these things in the time it's taken me to get this one working. So yeah, hopefully this is not something I'll have to do at any stage in the future. I would much rather not. But yeah, if you like what it is that I do, feel free to leave a donation below using my Ko-fi account. There are one-time only donations, or you can set up a subscription. Every cent helps keep the lights on here in the workshop. After all, this is my full-time job. If you want to send something in to me, make sure that you're checking out my social media in terms of when my repair seasons are going to be opening up. And as always, like, subscribe if you haven't already, and I will see you guys in the next video.